Hello everyone, I got myself a Mega 2. This has a MegaDrive 2 6-button controller shape and mode button. Everything is very similar to the MegaDrive 2 6-button controller, and that's because this is part of something called the Mega Game 2 that I think it's exclusive for the Portuguese market. As you can see, it has a square slot entry on the top, and as far as I know, this is something officially licensed by Sega to Echo Films company, and bigger differences are this button is a very clicky momentary switch, and this one is a slider. And so I bought this console and controller, and the controller was not working properly. I tested a lot of stuff, and sometimes it would work, sometimes it wouldn't, and there was a broken connection here next to the controller plug, and I repaired the broken connection, expecting that it would be an easy fix, but the instability of the controllers led me to think that there was some other broken wire somewhere over the cord. So I ordered the new cord on AliExpress, and after replacing the cord, some buttons did work, but other buttons didn't, especially the right button or the up button, and the controller was behaving erratically. So it was doing the same thing with the old cable, but I thought it would be a broken connection inside of it. But as I noticed later, replacing the cable wouldn't solve the controller issues. And after lots of hours, I spent almost 2 days trying to fault find this thing, and I think the problem is the main chip inside of these controllers. But as far as I know, even for the official Sega ones, you can't find the chip for these controllers, the IC, because it's very rare, and I think you can't find it as a spare. So if you have a Sega Nomad or a 6-button controller that needs a repair, you need to find another controller or another Nomad console to break it apart and use it as a donor. I think this controller has a broken chip inside. I'll show you some measurements I did with the console hooked up to the bench power supply, because it does some very big difference when the controller stops working, and it increases a lot the power consumption. So I think there's some kind of internal short on the chip, and it's one of those terrible blob chip things where you can't do anything at all. So I have a special idea for this controller. We'll try to make something special out of it to give it a new life. Follow along and let's see what we can do with it. Well, my main idea is to get this 6-button controller and try to transform it as a 3-button one, like this original one from Sega, where you have just 3 buttons and it's compatible with all games. This one uses a very less sophisticated chip inside. So the main idea is to get a chip similar to the one used on the official 1650 Sega controller and apply it to this model, transforming it to a 3-button controller. Even if it has 6 buttons, we can try to wire them for redundancy, okay, if you prefer to play on the small ones or if you prefer to play on the bigger ones. Okay, so please join me on this adventure. Let's try to make this thing possible. So inside these original Sega controllers, we have a very simple and common chip or common IC. It is a 74LS157, and this chip is responsible for the communication between the controller and the console. So let's try to adapt this chip of the old 3-button controller on to the new 6-button controller and make it work as a 3-button one. Let's try it. Let's open it up. I don't have any magic power things or something. Yeah, I need to use an actual screwdriver. So let's open it up. And here we have the circuit board. This is the cable I replaced. So I glued it because I had to use this grommet. The one that came on the AliExpress cable was very small and the cable was looping around and not getting well fixed. So I needed to repair that. So you can see and compare with the original controller. This is slightly different, probably to be a little bit cheaper. So I hooked up the console to the TV. One of the things that lets me believe that this controller is faulty from its blob chip is this code that appears here. This is a test ROM, and on this test ROM we can test the button pressing and also the controller identification by the console. So as you can see, the original controller identification here changes and the buttons all work as well. Okay, so this button is the mode button and those 3 buttons are the 3 buttons on the 6-button controller. So everything is working fine. We replace it by the 6-button controller and it's not being detected properly. And when you press the right key, is doing some funny business around there. So it doesn't recognize any of the button presses. Sometimes if you twist it, the buttons do different things, but at the moment is not working properly. Now the right button is working sometimes. You see, this is all very, very inconsistent. And as the right button is working, I can see on the bench power supply that the power is drawing from 0.43 amps to 0.37 amps. So some really funny business is happening in here on this controller. So this is the power supply and that is the power consumption with just the controller software and pressing buttons. And as you can see, the power consumption only changes slightly from 0.36 to 0.37 amps. But now I unplug the original controller and then I plug the one that's problematic, and as you can see the power consumption rises up quite a bit. And if I press the right button that is working right now, the power consumption goes down. Okay, so I've tested everything on the cables and there's no resistance between them when they are not welded to the board. So I'm pretty sure that this blob chip is not okay. Now I was using the rubber membrane with the contacts to make the tests on the controller, but usually I have a better tool for that. That is an old spudger that it's a bit knackered, and I've glued a rubber contact from an old GameGear that had the rubber contacts broken, and now I can go on any TV remote or game controller and do testing without having difficulties in bridging these contacts. So that's a very nice and useful tool. So let's rearrange the bench and get some weapons of mass construction. And by that I mean the microscope. So here we have the circuit board with a blob chip. This is a bit scratched up because I already did continuity testing on this pad, testing if the board flexing will change anything, testing contacts and resistances between the wires. I already did a lot of testing on this controller, and yeah, my conclusion is that the blob chip is done. So let's try to eliminate the blob chip and remake the connections, turning this 6-button controller into a 3-button one. After tracing some points on the original controller, and I tried to search on the internet for an actual schematic, I found a YouTube channel that did the reverse engineering of the first controller, so I would not have to do all the trace finding. And after having an actual schematic, it should be fairly simple to simply follow the connections and make everything go like the original controller. Okay, we just have to mimic with this structure. We just have to mimic the 3-button controller connections, and everything should be fine. One thing I should mention though is these cables, these AliExpress cables, they come with more or less the same colors of the original cable, but I had trouble with that also. These cables have all the colors mixed up on the connector, so don't take these colors for granted as a direct replacement with the same color, okay? Always use your multimeter and always check the continuities between the colors and the plug that enters the console, because on this cable none of the colors were matching the original cable order. Okay, very important thing. So now on to the fun part. We're actually using the tool to destroy. This is a grinder, a small polisher, and this is the first tool that I'm going to use to try to clean this blob chip. So let's do it. It sounds angry. Let's move away the chip. I think this will take forever. Maybe I should find something more aggressive. Clean this off and we'll show him what tools we got. Dremel. Well, I think that's enough, and I'll try to do it with the other tool from now on. Hello everyone, this is VoiceOver Retrofix, and during the next minutes I'll be cleaning the rest of the board with a finer sanding tool and the fiberglass pen. Utilizing the Dremel would be very risky. Next, I would check for continuities between the pads and the blob chip area to define where I should solder my wires, and then I could make a schematic of it. So the only thing that was left for me to do was to paint with a black marker the traces that would be useless from now on, and then it was finished. On to the next step. I made a very professional schematic to know where the buttons go to the location of the blob ship, and now I'll try to probe the continuity between the pads on the blob ship area and the controller connector to know to which pin each trace corresponds to, and to prepare my schematic to connect to the LS logic chip. I also took note of all the colors, and I'll try to relate them to the point inside of the connector. Let's plan the next phase then. So, with all the connections sorted out, I have my schematics, my fast schematics. I'll make good ones for you to see if you have this model of controller, for you to be able to recover it with the same method I'm doing here. And now let's grab some components and prepare them. First thing I'm going to do is to clean the ship legs and bend them out to make it as compact as possible. To clean it, I'm going to use a fiberglass brush, the one I've shown you before. So I'll go over the legs with a fiberglass pen. It looks absolutely new again. So I've tested the chip on the programmer TL8662 Plus, and testing on the software, it gives all normal results for the 74157 chip. Okay, so point of no return now. So I've bent all the pins outward like this. I'll clean it from one side, I'll clean it from the other side, and I think we are good to go. I have these helping hands with a heat shrink piece that I use on the crocodile clipper to avoid scratch marks and stuff when soldering cables, and this can help me not hurting too much the chip package. So I'll grab my fantastic pine seal soldering iron, that it works like a charm. It's something really good. I'm using it at 300 degrees. Sometimes I put more, sometimes I put less. It depends on how much temperature you need. Yeah, soldering always depends on heat transfer. So if you are soldering a bigger piece of metal or a bigger trace, you will always need some more temperature and power from your iron. If you are dealing with sensitive components, the thing you must do is if you need to use high temperature, you need to be fast. Okay, if you are fast, the temperature doesn't have enough time to rise too much, and probably you will never hurt that component if you are careful with that. So let's do it and tin this point. And our chip is tinned. By the way, I'm using this very good Amtech flux with a 3D printed extractor, but you can use a lot of other fluxes for this. Just simple generic flux will do. I hope you can see my chip is tinned, white and shiny, and I think we're good to go. After the 74 LS 157 I tinned, I have a 10 nanofarad capacitor and 8 10k resistors to make the pull-up resistors and mimic the 3-button controller. And the useless traces marked in black, so I know where not to put my efforts. So first thing, see where the rubber contacts go and see how much space do I have around this rubber membrane. Grab a pen and make a drawing of the rubber membrane position. D-pad, and then I'll have some space around here for my components. So let's see where we can put the chip and where the wires must go and all the pull-up resistors. So we need to take real care right now to guarantee that everything will fit and everything will not suffer from any kind of bending or pressure to lift traces off the board or something. Okay, let's see what we can do. Well, let's tin the pads. Nice and shiny. Up button, right button, down button, left button, start button, not used, A, B, C, Z, Y, X, and this is the mode one that we will not use. So let's try to connect some wires and add the pull-up resistors. Sometimes you need to change the order of what you're doing to make it easier. Cut some of these legs and prepare the chip. This is the pin where the 5 volts go, and I leave it big, and I'll start trimming by trimming the ground points and making all the ground connections. After doing all the ground connections, I'll do the pull-up resistors. So now that I know that all the short pins are grounded, let's make the ground connection. First pad soldered. Let's solder the second one. More solder. Yep, that's connected. That one is also well connected. This in here. And now, if I can make it focus, yeah, that's it. Just a tiny bit. Oh, come on. I don't like the way I'm doing this, but I think it will work. So, not focusing, but yeah. Yeah, I think we will have wire up till there. We will have it, yeah. They are close to each other, but they are not touching. That's the important bit. Okay, they can't touch. Shut up, phone. So let's continue the carnage. Continue le carnage. Killing a resistor and a chip same time. Two birds with one stone. This is a story to give nightmares to engineers. I think it looks okay. So let's snip this off really close to the resistor. So, voiceovering 2 times in a video. Well, this time I'm making a mess over the logic chip, soldering all the resistors and making sure that everything is soldered and desoldered 2 times because it was soldered on the wrong position. So then, after everything was okay, I soldered the 10 nanofarad capacitor, and then it was time to start soldering the wires. I soldered the wires first to the chip and then to the controller cable connections on the PCB. After that, I should have checked everything with the multimeter and compared with the schematic, but I've only checked for shorts. Well, let's see how it goes. Oh yeah, appreciate this beauty. Look at that. And it haven't got the wires connected up yet. Okay, so for now, and for reference, I'm pretty sure you can do a lot better than this. So, this is what I came up with. It's the first time doing it. And I think it looks awesome. Next phase. So, as we will only use 3 buttons of the controller, I was thinking about bridging something around here on the pads under the blob chip, but I found a very thin enameled wire and I'll bridge the test point right here. Okay, so because this wire is very thin, you almost can't see it, it's like a hair, it will be fine to bridge the points under the rubber membrane. So, let's continue the endless task. Yeah, this is getting fun. This is the fun part now, finally. Well, this has been a terrible journey. Lots and lots of work to make this bird's nest. But I think it looks acceptable. Let's clean it and test it. And you will test it with me, see if I'm lucky. So, well, I'm pretty nervous. Here I have, my bird nest controller, and I'm about to plug it in and see if it works. I have a D-pad membrane. Now let's see how it goes with this one. And let's see what happens. It can blow up, but you will not see it blow up. So I'll have an eye on the bench power supply. Power consumption didn't change, but the image on the screen changed a bit. And pressing down goes left. Oh, pressing down goes right. Pressing start does nothing. Okay. So, no good. It's not working. Let's reset. Whoops, resetting some buttons start working like crazy. No good. Something's wrong with this. Might be the connections. Might be the freaking board. It detects some button presses, but they are all crazy. I was convinced it was going to work, but you know, sometimes things don't go as planned, so I'll turn it off. So there's no shorts in terms of power consumption, nothing goes crazy, but it's not working yet. Well, I'll have a good night of sleep if I can, and let's grab this thing tomorrow. I hope we can solve it on the next day. Look at that. So much hard work just to save a controller. Oh well, a moment of truth here. Let's see how it goes. I need to plug in the original controller to select the ROM. Everything is working with the original one. Let me take it apart. Let me take it out and put the new one. No, something wrong again. Only the down button works. Ah, no. Don't understand. So, instead of raging like an idiot or rage quitting the project, I decided to make a sensible thing to do, measuring voltages. Let's turn the console on and see if we get the 5 volts on the controller. I have my multimeter here, and let's see how much do we get on the 5 volt pin. So console is on, and if I measure between ground and 5 volts, I have 1 volt on the multimeter, and I think there's something wrong in the way I wire this controller. If I power on the system and if I search for 5 volts on the controller connector, they are on the top rightmost pin, and that's exactly the pin where I don't have the 5 volts, but I have the up button. That's why when I press the up button, the power consumption on the power supply rised up. Yep, I think I've got my wired up backwards. Eat it. I've soldered the wires from the cable on the board, on the circuit board, wrongly to the chip. So that's those little cables I'm going to change. What do you think? Is this going to be the last test of the 2000th revision of the bird nest controller? Look at it. Looks like spaghetti. So let's finally test it and see if it works. I'll plug in the original controller. I'll enter the test ROM, plug it out. Let's look at the bench power supply. Oops, the detection is looking good. Let's see what happens. Yes! Success! It works! X button works, A button works. It's working! Finally! Fucking finally! It's working! C button works, B button works, A button works, start button works. The whole D-pad is working. Oh, finally! Yes! Yes, 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 yes! Let's reset it in case to see if it's not a fluke. And it's working again. And the power draw and the power supply is okay. It's acceptable. No difference. Yes! So many days. So many hours to try to find what was wrong. And I wired the chip wrong. Yeah, it was wrongly wired to the controller board. So I needed to reverse everything because the cable was well soldered, but I misinterpreted the relation with the connector pin out and the chip pin out, and it made me lose 3 freaking days troubleshooting and try different solutions while the base was wrong. So in other projects, please check your stuff 3, 4, 5 times, whatever times you need, because it's better to lose time checking something and make sure that it is fully correct than wasting 3 or 4 days banging your head against the wall, asking yourself why it doesn't work, and not getting anywhere. Okay? Yeah, that's the best advice I can give you. I'll reassemble it and play some games. I can't believe it. I still can't believe it. Yes, it works. Yes! Turn on the bench power supply and final testing. I'll turn on the console and I'll plug in the Mega 2 one. It looks nice. All the buttons have a nice feeling. So let's plug it in. Bench power supply is okay. Yeah, it goes down and it goes up. So these are working. Yep, right, left, up, down, start, A, B, C, X, Y, Z. Okay, it works as a 3-button controller, but I can use the smaller ones and I can use the big ones. Yes! Finally! Finally, and it looks nice. Controller saved and console saved. And now, after this controller is fixed, retro-fixed, I think I deserve a beer. Thank you for watching. Thank you very much for watching. Bye!